Hey everybody, welcome to the last and final video of the final review for our exercise physiology review series. Now, throughout the semester, we've learned and discussed about how the body responds to exercise through the cardiovascular, respiratory, muscular, and metabolic systems. Now, today I'll finish by reviewing environmental physiology and explaining how the body maintains homeostasis when exercising in challenging environments such as extreme heat, high altitude, and cold temperatures. Now, one of the central themes of the course has been that exercise itself is a physiological stressor. Now, environmental conditions can amplify that stress, requiring the body to make additional adaptations to maintain normal function and continue producing ATP. Now, I'm doing Bosu squats here, and as I'm doing these Bosu squats, the exercise challenges my neuromuscular system, but regardless of the exercise being performed, my body is constantly working to maintain a stable internal environment. All right? That's the whole point of homeostasis, in stable internal environment. When exercising in a hot environment, skeletal muscles generate large amounts of heat as ATP is broken down. In fact, only a small percentage of the heat released from ATP is converted into movement, while the majority is overall released. Only a small percentage of energy released from ATP. That's what I meant. Now, as core body temp begins to rise, the hypothalamus acts as the body's thermostat. It's going to initiate several physiological responses to promote heat loss. One of the first responses being vasodilation, where blood vessels near the skin widen to increase blood flow and transfer heat away from the body's core. At the same time, sweat glands become more active. As sweat evaporates from the skin, heat is removed from the body through evaporative cooling, and our ability to cool ourselves depends on several environmental conditions that make up the heat stress index. This is going to include air temp, humidity, radiant heat from sources such as direct sunlight. Humidity is especially important because it limits the evaporation of sweat. If sweat cannot evaporate, the body's ability to cool itself becomes much less effective and overall increases the risk of heat-related illnesses. Now we're transitioning into some sideways lunges on the Bosu ball. And, now that I've increased the intensity with walking lunges, my body is going to produce even more metabolic heat. If heat production exceeds heat loss, the risk of heat illness will increase. And early stages of heat illness may include, muscle cramps, fatigue, dizziness, dehydration. And if these symptoms progress, an individual may develop heat exhaustion, which is characterized by heavy sweating, weakness, nausea, and an overall inability to continue exercising safely. Now, I'm sure majority of you are probably athletes. If not, you've probably done some form of physical labor outside in the heat at some point, and you might have experienced some of these symptoms. Now, the most severe form of heat illness is heat stroke, which is a medical emergency, and it's in which the body's thermoregulatory mechanisms begin to fail. All right, core temp rises too rapidly, neurological symptoms develop, and immediate medical intervention is required. Fortunately, there's several strategies to reduce the risk of heat injury, such as proper hydration, heat acclimatization, and wearing lightweight clothing, and overall monitoring environmental conditions, all to improve safety during exercise. Another major environmental stress discussed this semester was altitude. So as altitude increases, atmospheric pressure decreases, which lowers the partial pressure of oxygen. So although the percentage of oxygen in the air remains roughly 21%, fewer oxygen molecules are available overall. Now, because less oxygen reaches the bloodstream, aerobic ATP production becomes more difficult, especially during prolonged exercise. Now, one of the body's immediate responses is an increase in ventilation, when breathing becomes faster and deeper, and an overall attempt to increase oxygen uptake. Now, heart rate also increases as the cardiovascular system attempts to deliver sufficient oxygen to working muscles. Now, with continued exposure, the body begins a process called altitude acclimatization, in which the kidneys will release more erythropoietin, or EPO, which is going to stimulate more an increased production of additional red blood cells. And this is going to increase the blood's oxygen carrying capacity and partially restore oxygen delivery during exercise. Now, although acclimatization improves performance, endurance capacity at high altitude often remains below Endurance capacity at high altitude often remains below sea level performance because oxygen availability is still reduced overall. Now, our notes also introduce hyperbaric environments where the atmospheric pressure is greater than normal. Now, increased pressure allows more oxygen to dissolve into the blood. It overall demonstrates how changes in environmental pressure directly influence oxygen transport. We kind of briefly touched on that, but we're transitioning into cold exposure, and in cold environments, the body's going to respond with vasoconstriction, which is reducing the blood flow into the skin to conserve heat. And if the body temp continues to fall, an individual may develop hypothermia, where core temps drop below normal. As hypothermia progresses, muscle function, nerve conduction, coordination, and cognitive function all become impaired. And treatment involves, removing the individual from cold environment, replacing wet clothing with dry clothing, and gradually restoring body temp while seeking appropriate medical care.